Okay, so we're going to be going through some revision questions. The first one, you're just given an expression to simplify. So when you have more than one operation in the same expression, you have to ensure that you use BODMAS or PEMDAS. PEMDAS just means parentheses, exponents, multiplication or division, then addition or subtraction. So you have to do it in that order. All right, so I'm just going to write PEMDAS here, just to remind you of the order. And parentheses is just a fancy name for brackets. Exponents is a fancy name for powers. Okay, there are no parentheses or brackets here. There are no exponents, but we do have multiplication, so we're going to do that first. Okay, the rules for directed numbers says that when you're multiplying two numbers with different signs, you will always get a negative product. So this is going to be -8. All right, so we have addition, so we're going to do that after. And remember, we already multiplied these two numbers to get -8. So this is going to become -3 plus -8. And again, you'll have to go back to the rules for directed numbers to help you. Okay, so the rules for directed numbers says that when we're adding two numbers with the same sign, we add and take the sign. So we're going to add 3 plus 8 is 11, and we take the sign that the two numbers have. Okay, so the final answer is going to be -11. Okay, question 2, we have brackets here, but we have a number on the outside of the brackets. So whenever this happens, you're going to have to do what is called expanding the brackets. That just means you're going to multiply the number on the outside by each number on the inside of the brackets. So what I like to do, I like to draw arrows from the number on the outside to each number on the inside of the brackets. And you're going to be multiplying. So I'm going to draw a multiplication sign just to show that we're multiplying the number on the outside times each number on the inside of the brackets. Okay, so the first one is going to be 2 times x. That's going to give us 2x. Because we know once a number is being multiplied by a variable, it becomes the coefficient. So you would put the coefficient in front of the variable. So 2 times x is the same thing as 2x. All right, another thing as well, you need to ensure that you rewrite the same operation sign that is in the pair of brackets. So there was a plus sign here, that is why I'm writing a plus sign here as well. All right, so we have 2 times 1, that's going to give you 2 minus 3. And we still can simplify 2 minus 3, so that is going to give us, according to the rules for directed numbers, that's going to give us -1. So our final answer would be 2x plus -1. Okay, number 3, we have powers or exponents to deal with. Now, there are laws that help us to easier simplify, or it makes it easier for us to simplify when we're working with numbers that have indices or powers or exponents. So we can use I think it was 7 laws. Yes, the 7 laws that we discussed. Now, the operation that we're doing is division. And if we're going to use the law of indices for division, we have to ensure that the base is the same. Okay, so let's check the base. The base is the same for both of them. The base would be 3. So since the base is the same, we can go ahead and use the law of indices for division. All right, so the law of indices for division says that when you're dividing two numbers with the same base, you are going to keep the same base. So I'm going to write back the same base, which is 3, and subtract the powers. So the power would be 4 minus 3. And our final answer, we can simplify that to 3 to the first power. Okay, number 4. We have 100 x squared minus 64. Okay, when you're asked to factorize, keep in mind that the instructions for number 4 should have been factorized. So we're supposed to factorize this expression, right? Now, whenever you're asked to factorize algebraic expressions in particular, look to see if it is a difference of squares before you go ahead and find the HCF and all of that. So we can notice here that 10, I can square a number to get, sorry, I didn't mean 10, 100, right? 100, I can square a number to get 100. I can also square x to get x squared, and I can also square 64, yes. I can square a number to get 64. All right, so what we're going to do, we're going to write each term as a square of another number. This is what I mean. Okay, so 10, I'm going to write that as 10 squared x squared minus 16 squared. Okay, whenever you have your expression in this form, we can also write it like this. So what you're going to do, we're going to write it as 10x minus 16 plus, sorry, we haven't gotten to the plus part as yet. So it's going to be 10x. Okay, this is where we would write our plus sign. So plus 16 close brackets. Okay, so this is how you would factorize a difference of squares. That means the coefficient can be written as a square of another number. The constant here as well can be written as the square of another number. Also keep in mind that it says difference of squares. So if this were a plus sign, then I would not be able to call this a difference of squares. So difference implies subtraction. Okay, number 5. All right, it also tells us to factorize. So it says 9x squared plus 27. Now, this would not be a difference of squares. Reason being, yes, I can square 3 to get 9, but I can't square any number to get 27. All right, so what we're going to do, we're just going to factorize it using the HCF. Okay, to find the HCF, all we have to do is write each coefficient as a product of its prime factors. So I'm going to start with the first term, and I'm going to write that coefficient as a product of its prime factors. So that would be 3 times 3. Then any variables with powers that you have, you're going to write that in expanded form. Okay, let's do the same thing for the second term, which is 27. So that is going to give us, just give me a minute. Right, that's just going to give us 3 times 3 times 3. And remember, we're writing it as a product of its prime factors only. Okay, for coefficients, for this coefficient and this constant here, 9 and 27, because they're small numbers, it's easy for you to find the HCF. We already know the biggest number that can go into both 9 and 27 would be 9. But this would be useful for bigger numbers that you can't think of the HCF from the top of your head, right? Okay, so you don't have to use this method if you already know the highest common factor for the coefficient and the constant. But like I said, you can use this method for when you're working with very large numbers and you can't think of the HCF right away. All right, so what we're going to do, we're going to circle any pairs of common factors that we can find. Okay, there's no x for us to circle here, so that's basically it. And the 8th is then going to be, so what we're going to do, we're going to write the number in each pair. Okay, the number in this pair is 3. Then we're going to multiply it times the number in this pair, which is also 3. And that gives us our 8th, which is 9. Okay, you could have done all of this without, you could have found the 8th without doing all of this, but still, you can use this method, like I said, for bigger numbers. Okay, so what do we do with this, with this 8th? Sorry. We're going to divide each term by the 8th that we just found. Okay, after we do that, we're going to write the 8th on the outside of a pair of empty brackets. Then we go ahead and divide. Alright, so 9 into 9 is 1. Alright, 9 into 27 would be 3 times. Okay, so 1x squared, same thing as x squared, because the 1 in front of the x squared is not going to affect anything. We have a plus sign, so I'm going to rewrite that. Then I have 3 over 1. 3 over 1 is the same thing as 3, so I'm going to put 3 here. And that's basically it for this expression. Okay, this one says simplify 3x minus 8y plus 2x. Now, what we're going to do, we're going to look for what we call like terms. So like terms are terms with the same variable raised to the same power. Now keep in mind, like terms can have different coefficients. But what must be the same? The variable must be the same, and the power that the variable has must be the same. Okay, so let's look for any like terms in this expression. Okay, I'm seeing a 3x. And I'm also seeing another term with the same variable raised to the same power. Keep in mind, even though there's no power there, there is a power of 1. So whenever you don't have a coefficient, you can put a coefficient of 1. When there's no power on the variable, you can put a power of 1 as well. And this works for numbers too. So if you want to put a power on your number, you can write a power of 1 without changing its value. Okay, so what do we do after we identify the like terms? We're going to write them beside each other. Okay, so I'm just rewriting the same expression, but I am writing the like terms beside each other. Okay, after you do that, you're going to go ahead and combine your like terms. So to combine your like terms, that means you're going to either add or subtract their coefficients. So we have 2 like terms here. And these are the coefficients of the 2 like terms. In this case, we're going to be adding because there's a plus sign between the 2 like terms. So we're going to add 3 plus 2, that gives us 5, and we keep the same variable. Okay, so you either add or subtract the coefficients, and you keep the same variable that the like terms have. Then you rewrite everything else, so this part is important as well. Don't forget to rewrite everything else that you did not touch. So we didn't do anything to 8y. But the 8y is still a part of the expression. So once you combine your like terms, don't forget to rewrite everything else that you did not simplify or combine. Okay, this one says solve the following system of equations. Now we have 2 algebraic methods for solving simultaneous equations. So these would be a pair of simultaneous equations. Okay, you have to choose between the substitution method and the elimination method. Now, you can use the elimination method. The elimination method would be best for when you have a term with the same variable. Okay, so sorry, when you have a term with the same variable and the same coefficient, my bad. Okay, when you have a term in both equations with the same variable and the same coefficient, then the elimination method would be best. Meaning that if you look at this pair of simultaneous equations, we have a term with the same coefficient, which is 2 in this case. Alright, so you notice that we have a term with the same coefficient and the same variable. So the variable would be y in both terms. Okay, so how do we use the elimination method? The elimination method is when you are going to eliminate one of the variables. So that means we are going to have to use, I like to call it the SSS method. Okay, so SSS stands for same sign subtract. So if the term with the same variable and the same coefficient, if those terms have the same sign, meaning that both of them are positive or both of them are negative, then you would subtract them from each other. But if they have different signs, so if they have different signs, you're going to do the opposite. Okay, so different signs add. So same sign subtract, different signs you're going to add. Okay, so let's look at the term with the same coefficient and the same variable. They have different signs in this case. So what we're going to do, we're going to be adding. We're going to be doing the opposite. Alright, so when we add these terms, we also have to add up all of the other terms in the pair of equations that we have. So we're going to be adding this and the constants together as well. Okay, so we know how to add up our like terms. So to add your like terms, you have to either add or subtract. And whatever coefficient you get, you're going to put that there, then you keep the same variable. Alright, so we're going to add in this case, 3 plus 5 is going to give you 8. And we're going to keep the same variable, which is x. And we already know how to add our constants. So 12 plus 4 is going to give you 16. Okay, once you've done that, you're just going to solve the equation. And to solve your equation, that means you have to do the operations that will you're going to have to do the operations that will isolate your variable. That means your variable is going to be on one side of the equation by itself. So if we want our variable, which is x, to be on one side of the equation by itself, we're going to have to get rid of that 8. So how do we get rid of that 8? Whenever you want to get rid of a coefficient, you're just going to divide both sides of your equation by that coefficient. Okay, so if I want to get rid of 8, and 8 is a coefficient, I'm going to divide both sides of the equation by the coefficient. Okay, so once you've done that, you can just go ahead and cross out that 8 to show that it's gone from this side. Then we can solve what is on the other side. Okay, so 8 into 16 would be 2 times. So x is equal to 2. But we're still not finished. Remember, there are 2 variables in this pair of simultaneous equations. So when you're solving simultaneous equations, you're supposed to get an answer for the 2 variables that are there. But we still don't have a value for y, so we need to find that. Okay, so to get the value for y, it's very, very simple. All you have to do is choose one of the equations that you want to work with. So I'm going to choose the second equation, and it doesn't matter which one you choose. So you can choose any one that you want, or any one that you think will be easier. After you do that, you're going to then substitute the value that you have for one of the variables into the equation that you just chose. Okay, so that means, when I say substitute, that means I'm going to replace x with the value for x that I have. We also have to pay very close attention to how we substitute. This is what I mean. Alright, so this is not going to become 52. This is going to be 5 times 2. Now keep in mind that the number in front of the variable is being multiplied by the variable. So when I'm going to substitute 2 in this equation, I cannot write 52. It has to be 5 times 2, because 5x is another way of saying 5 times x. And remember to rewrite everything else in the equation that you did not do anything with. Okay, so after we do that, we're going to go ahead and multiply first. So that's going to give you 10. 2y is equal to 4. Alright, but we're still not finished. We still need to get a value for y. And to get the value for y, we're going to have to solve the equation. So that means we have to get our variable or letter, which is y, on one side of the equation by itself. So how am I going to do that? I have to get rid of two numbers that are on the same side as y. So we have 10 on the same side as y. We also have negative 2 on the same side as y. So what I would suggest, try to get rid of the constants first before you get rid of the coefficients. So that means I'm going to get rid of 10 before I get rid of 2. Okay, how do you get rid of the 10? Now, this is a positive 10. So to get rid of that 10, I'm going to do the opposite, which is subtract. So if I wanted to put the sign that 10 has, I would put a plus sign to show that it is positive. So to get rid of the 10 or to cancel the 10 from this side, I'm going to subtract 10. And anything you do to one side of your equation, you must do the same thing to the other side. So I'm going to subtract 10 over here as well. Okay, once you've done that, you can cross out the constant that you just got rid of. And you rewrite everything else. So this is going to be negative 2y is equal to. Alright, so when you get to this part, you have to go back to your rules for directed numbers. And the rules for directed numbers says when you want to subtract, you can change to add the opposite. So you would end up with 4. So we're going to change that subtract that is here to add. Then we're going to change this to a negative 10. And we would get, since we're adding two numbers, the rules for directed numbers says when you're adding two numbers with different signs, you subtract and take the sign of the larger number. So that means I'm going to say 10 minus 4 is 6. And I take the sign of the larger number, which is negative. So we end up with negative 6. Okay, you're going to have to use the rules for directed numbers a lot. But again, we have to get rid of the negative 2. So we're going to go back to our rules for directed numbers. That says when you want to, that says when you want to when you want to divide one number into another number and they have different signs, or this would be the same sign, when you want to divide one number into the other number and they have the same sign, you're going to get a positive answer. Okay, so we already know how to get rid of coefficients. So since negative 2 is a coefficient, we just have to divide both sides of the equation by that coefficient. Okay, so cross this out to show that it's now gone. Now over here, we're dividing negative 2 into negative 6. We're dividing and they have the same sign. So we're going to get a positive answer. So this is going to be positive 3. And the negative 2 is now gone. So we're only left with y. Okay, so we can say that this is solved because we have the variable on one side of the equation by itself. So our final answer is going to be x is 2 and y is equal to positive 3. And that's basically it. Okay, it says make y the subject of the equation. Now, this is similar to when you're solving equations. The only difference is that we're not going to have a final answer that is a number. So, like when we solved for y here, we got y is equal to 3. The answer that we get is not going to be a number. Now, the goal is basically the same though. The goal is to get whatever variable you want to be the subject. You have to get this variable on one side of the equation by itself. So it is like you're solving, but you're not going to get a number as your final answer. Okay, the only goal is to just put the other terms on the opposite side of your equation and to get y on one side of the equation by itself. Okay, so to do that, I'm going to have to figure out how to get rid of this x and how to get rid of the 2 in front of y. Okay, x here would represent a constant. So what do we do when we want to get rid of constants? We're going to look at the sign that the constant has, and we're going to do the opposite. Okay, so this x here would be a positive x. So whenever a number does not have a sign in front of it, it is a positive number, right? Okay, so seeing that it is a positive number, I'm going to do the opposite, which is subtract, and I'm going to subtract x. So once you've done that, you've basically cancelled out this variable from this side. Now, anything you do to one side, you have to do the same thing to the other side of your equation. So we're going to end up with that. After that, you're going to rewrite what you have left. So on this side, it is 8 minus x. We don't know the value for x, so we can simplify this into one number. So I'm just going to rewrite what we have on this side in one line. Okay, but we're still not finished. Remember, to make a variable the subject, we have to get the variable on one side of the equation by itself. So we still have a 2 that is on the same side as y. So to get rid of this 2, we know how to get rid of coefficients. So whenever you want to get rid of a coefficient, you're going to divide both sides of the equation by that coefficient. Okay, once you've done that, you can cross out the coefficient and write what you have left. So the final answer is going to be 8 minus x all over 2. Okay, number 9, it says find x in this right angle triangle. Okay, we know that for right angle triangles, we can use Pythagoras' theorem. So let's use that theorem to find x. Alright, we have to pay very close attention to how we write our equation though. So what I like to do, I like to write out my equation and label the sides of my triangle. Now keep in mind that A represents the hypotenuse. And remember, the hypotenuse is the side that is opposite the right angle. So what I like to do is draw an arrow from the right angle to tell which side should be my hypotenuse. Now it's going to be 5, the 5-unit side in this case. B and C just represent the legs of the right angle triangle. So the other 2 sides that are not the hypotenuse would be the legs. Okay, after that, I'm just going to go ahead and fill in the numbers. So A would be 5. So I'm going to put 5 squared. Okay, B, it doesn't matter which one you label, B or C. Just label the legs, either B or C. Okay, so B in this case would be 4. And C in this case would be x. And remember this squared, so it's going to become x squared. Alright, after that, we're going to go ahead and figure out now how can we solve for x. So remember, to solve for a variable, you have to get the variable on one side of the equation by itself. So I have the 4 squared to get rid of, and I have to remove the squared that is on this x as well. So keep that in mind. Alright, so I'm going to start by figuring out what 5 squared is and 4 squared is. So this is going to be 25 and this is going to be 16. Okay, so 16, we're going to have to figure out how to get rid of the 16 first. And since 16 is a constant, what I'm going to do, I'm going to write the sign that this 16 should have. Since there's no sign there, that means the 16 is positive, and I'm going to do the opposite, which is subtract. Then I'm going to do the same thing on the other side of the equation. Okay, so once you've done that, you can cross out that constant and you write what you have left. Okay, so 25 minus 16, instead of writing that again, I'm just going to go ahead and find the answer right away. So that is going to give us 9, and we have x squared on this side. But we're still not finished. Remember, we need to get rid of all of the numbers and terms that are on the same side as x. So there is still a squared there for me to get rid of. So how do we get rid of a squared symbol? All we have to do is do the opposite of square. The opposite of square is square root. So if you want to get rid of a squared, just square root on both sides of your equation. Okay, so we can cross out the squared symbol, sorry. And that's going to leave us with x. And remember not to rewrite the square root sign. Reason being is that these cancel out each other. So once you square root the squared, the root sign is no longer there because they cancel out each other. Okay, so the square root of 9 would be 3. If you notice that you have a number where you can't think of the square root for it, you can leave it as is. So you could also write x is equal to the square root of 9, and that's perfectly fine. Okay, so the final answer is going to be x is equal to 3 units. And that's basically it. Okay, it says answer questions A to D using the circle below. Okay, the first one asks us to find the area of this circle. So the formula for finding the area is A is equal to, I'm going to call this A subscript C to show that it is the area of the circle. That's going to be pi r squared. And it says we must use pi is equal to 22 over 7. Okay, so R represents the radius. So the radius would be the distance from the center of the circle to one point on the circumference of the circle. So in this case, the radius would be 7 centimeters. I'm going to add the units to my final answer. Alright, so remember there's a square there, so we're going to have to write that as well. Okay, so remember, BODMAS or PEMDAS, you have to do powers before you multiply. So we're going to find out what 7 squared is before we multiply. So that's going to be, 7 squared would be 7 times 7, which is 49. And we're just going to go ahead and multiply. Okay, so when I want to multiply this, there are two ways that you can do it. You can just cancel by saying 7 into 49 would be 7. 22 times 7 would give you 154. Or you can write the whole number as a fraction by putting it over 1. And when you want to multiply two fractions, you would end up with you would multiply the numerators and multiply the denominators. So multiplying the numerators, that would be 22 times 49, I get 1078. And we're multiplying the denominators now. So it's going to be 7 times 1, that would give you 7. Then you can go ahead and divide. So when I divide 1078 by 7, I get 154. So we get the same answer. Now this part is very important as well. Remember, when you're finding area, your units are going to be squared. So this is going to become centimeters squared. And that's our final answer. Okay, the circumference of the circle now. So we're going to have to use our formula again. So the circumference, or capital C, is 2 pi r and all we have to do is just fill in the information in our formula and we solve. So it says that we must use pi is equal to 22 over 7. So that is why when I substitute for pi, I'm writing 22 over 7 there. Okay, R was 7 centimeters. So I'm going to put 7 in place of R. And like I said, if you want, you can write the whole numbers as fractions by putting it over 1. Then multiply the numerators and the denominators. So 2 times 22 times 7, I get 308. Then 1 times 7 times 1 would be 7. So we're just going to divide 308 by 7, and I get 44. So keep in mind that you're not going to square these units, because the circumference is actually the distance around the circle. So we don't square the units when we're talking about distance. We only square the units when we're talking about area. Okay, how do we find the length of the arc of the minor sector? Now, when you want to find the length of an arc, you're going to use this formula. Now, keep in mind that we're finding a part of the circumference. So what I'm going to do, I'm going to write theta over 360. I'm going to write this as L subscript A, length of the arc. We're finding a part of the circumference. So it's going to be theta. We know we use theta to represent an angle. So it's going to be theta over 360 times the circumference. So the formula for the circumference was 2 pi r. So I'm going to write that here. 2 pi r. Okay, so going back to the diagram, remember this section in red would be the arc for this minor sector. The major sector would be the bigger sector cut from the circle here. Alright, so how do we find the length of the arc now? Theta represents the angle that is formed by the arc. So we have an angle of 100 degrees. So where you have theta, that is where you put the angle. So I'm going to put 100 over 360 degrees. And then remember, we don't have to redo this part because we already know what we would get when we multiply 2 times pi times r. We got 44. So instead of writing that information all over again, I'm just going to put 44 to make things easier. Okay, so one way we can multiply these is to write 44 over 1 and multiply the numerators and the denominators. So 100 times 44 would give us 4,400, and 360 times 1 would just be the same number. Then we divide. Okay, so the final answer I got, when you're writing your final answer, don't write all of the digits that you get from the calculator. Just keep it to say no more than 1 to 3 decimal places. So I'm going to write this to 1 decimal place, or you can round it to the nearest whole number if you want. So our final answer is going to be 12.2 to the nearest tenths. And remember your units as well. So the units that you're going to use the unit that you were given the radius in. So we were given the radius in centimeters. That means our final answer must be in centimeters. Okay, next question, we have the area of the minor sector. So what we're going to do, we're going to go ahead and write our formula. So keep in mind that we're finding a part of the total area of the circle. So it's going to be theta over 360 times. Alright, so we're going to multiply this times the area of the circle, which is pi r squared. That is because we're finding a part of the total area of the circle. Remember, we already know what we would get when we multiply pi times r squared. We got 154. So I'm just going to substitute 154 here. Okay, so this would be theta over 360. And again, theta represents the angle that is formed in the sector. So we said that that was 100 degrees. Over 360. Okay, so I'm going to put this over 1. I'm going to multiply my numerators and denominators. So this would be 15,400 over 360. Okay, so our final answer is going to be, I got 42.77 and a whole string of sevens, but I'm going to round that to one decimal place, and that is going to be 42.8. Now keep in mind that we're finding area, so that means we're going to square our units. So it's not just going to be centimeters, it's going to be centimeters squared, because we're asked to find area. Okay, question E, the area of the triangle. Now, how do we find the area of the triangle that is formed in the sector? Now, we're going to have to use a different formula for that. Sorry, I'm writing this too early. Okay, so this is the formula that we are going to have to use. So I'm going to put area of triangle. So AT for short is half r squared, and we already know r represents the radius, sine theta. Okay, so all you have to do, students, just substitute the information from your circle in the formula. So that's going to be half. We know r was 7 centimeters, so I'm going to put times 7 squared times sine. So we know that the angle that was formed in the sector was or the angle in the triangle, as a matter of fact. So the angle in the triangle is 100 degrees. So we're going to put that for theta. Okay, so powers first. We're going to find out what 7 squared is before we multiply. That's going to give you 49. And you can also go ahead and find out what sine 100 is. So sine 100 is, I got 0.985. Now, there's one more thing that we need to keep in mind. When you're finding the sine or cos or tan of any angle, students, ensure that your calculator is in degrees. This part is very important. Now notice that we were given the angle in degrees. So to set your calculator to degrees, again, if you're using a phone calculator, you're going to see DEG in the left-hand corner of the phone screen or the tablet screen. If you're using a scientific calculator, you're going to have to press mode, and you're going to have to change that to degrees. So you should be seeing DEG or a small d at the top of your screen. Alright, so just keep in mind, this part is very important. If you don't do that part, you're going to get the incorrect answer. Okay, so we're going to go ahead and multiply half times 49. You can write half as a decimal as 0.5. So I'm going to put in 0.5 times 49 times 0.985. And keep in mind, I also rounded the number that I got for sine 100. I rounded that to 3 decimal places. So that is how I got this. Okay, so our final answer after we multiply is going to be 24. I'm just going to round it to 1 decimal place. 24.1 to 1 decimal place. Remember, we're talking about area again, so it's going to be centimeters squared. Okay, so we're asked to find the area of the segment CD. Okay, so the segment would be this section here. Alright, so how do we find the segment? Now keep in mind that we found the sector, so the sector would be this area here. I'm trying not to draw on it too much. So the sector is the part that I'm shading in orange. The parts that we also found the area of the triangle. So the triangle would be the part that I shade in green. Now to find the area of the segment, all you have to do is subtract the area of the triangle, the part in green, from the area of the sector. Okay, so we know the area of the sector, we know the area of the triangle as well. So what I'm going to do, I'm going to say the area of the segments is equal to area of the sector. Let me put SEG for short. The area of the sector minus the area of the triangle. Okay, so that is how you find the segment. You find the segment by subtracting the area of the sector from the area of the triangle. Sorry, it's the other way around, but you get what I'm trying to say. Okay, so we said the area of the sector was 42.8 centimeters squared. I'm going to add my units to my final answer. And we said that the area of the triangle was 24.1. Okay, so our final answer is going to be 18.7. And remember to add your units to your final answer, so it's going to be centimeters squared because again, we're asked to find the area. Okay, I'm going to be doing questions 11 and 12 in the next video. Okay, sorry, 11, 12, and 13.